Now we'll discuss a real example of RSA. It's real in the sense that the size of the primes that we start with, 150 digit long, makes it essentially uncrackable. But on the other hand, best practice these days is to have random primes about 300 digits or so in length. So the process to use is the following. The process we've used here is, first of all, enter, using Maple, mathematics software package, a random 150 digit number. And then ask Maple, and call that PP. Then ask Maple to compute the next primed on or after PP. Maple does that, and it comes up with this number here. The actual number is written down in the notes for the course. So notice here in particular that 362,399, it's only another 37 until we come to the next prime. And similarly, we enter a random number QQ. Q will be the next prime on or after QQ, and it comes out to this. And once again, it's not many steps, it's not many numbers that need to be checked. It's another 37. Next step, step 2, we compute n equal to PQ. This will give us, in fact, in this case, a 300 digit number ending in 36149. And we compute P minus 1 times Q minus 1. That will be the number M here. And that gives us this number here, which again is 300 digits. Next step is to find a number E, a prime. We typically would take a prime, E, in the range bigger than or equal to 3 less than M, which is going to be not a divisor of M. In other words, the greatest common divisor of E and M will be 1. So you just ask Maple to check what's the remainder after dividing M by 3, and it's 0. So in other words, 3 does divide M evenly. Similarly, 5 divides M evenly, but 7 does not. The remainder is 6. So that tells us that 7, which of course is prime, the greatest common divisor of E and M will equal 1 in that particular case. So we take E to be 7. We next compute the number D, which when multiplied by E gives us 1 modulo M. We ask Maple to do that, and this is the command to use. And the answer is this, 300 digits long again, ending in 85643. Bob now publishes N and E and keeps D secret. It's probably important at this stage, it certainly is good practice, that Bob destroys the number P, the number Q, and the number M, and also all computations used in the process. Suppose now that Alice wants to use Bob's public key to send him a private message. So, for example, take the highly confidential message. The key is under the mat by the front door. The first step is for Alice to translate that into a number. So by the translation process we've discussed previously, we obtain this number here, 20 corresponding to the fact that the letter T was the 20th letter in the alphabet, 08, H is the 8th letter in the alphabet, 05, E is the 5th letter in the alphabet, and then the next 2 will correspond to space between the and key, and so on. But the resulting number is perhaps not long enough for the amount of security we would like. So then we pad out the number as follows. We begin with 99 and end with 00. The reason for this is that neither 99 nor 00 correspond to letters of the alphabet, numerals, or punctuation symbols. And then we put an even number of digits in between. Alice now uses Maple, for example, to raise W to the power E modulo N. Remember that E and N were the 2 parts of Bob's public key. And this particular form of expressing W to the power E is used to tell Maple that it should use the type of algorithm that we've discussed previously. If this is not done, Maple will overload. The result is this number here, the last 5 digits being 73335. Alice then publishes C. Now, anybody in the world can read C in principle, but nobody can, except for Bob with his private key, can decrypt C back into the original number W. For Bob to decrypt C, he uses the same command in Maple as did Alice. C now is Alice's encrypted message. D is the private key that Bob has and only Bob has. When he does that, the result is this: the junk and then the rest of the original message. Of course, that's exactly the same as W up here. The padding is now stripped off, and Bob now ends up with the message: the key is under the mat by the front door.